Hello and welcome to Math with Mrs. Becker. Today in Algebra 2 we are starting Chapter 3. Now Chapter 3 focuses on systems of linear equations. A system of equations means that you have a set of two or more equations and they contain two or more variables. I know that's a little bit wordy, so here's a visual for you. Let's say I have y equals 2x plus 1 and 4x plus 3y equals 8. Now this would be considered a system of equations. I have two or more equations and each equation has two or more variables. We are working with linear systems, and what that means is that when we try to solve, if we graph them, everything is going to form a line. Okay? The solution of a system of equation is the set of all points that satisfy each equation. What that means is you're looking for the ordered pair that if you plug them into each equation, you would end up with a true statement. What we're really looking for are points of intersection. Let's keep on going. When you are graphing a system of two equations, the solution is the set of points where the two lines intersect. I guess I got excited and just jumped ahead a slide. A point is a solution to a system of both equations. Okay, so what you're doing, you're looking for the intersection. The point is a solution if it makes both equations true. So once you find that intersection point, you want to check and make sure that yes, this is the solution. So you take the x and y from the ordered pair and you fill it back into each equation and make sure that you get a true statement. So starting us off, they're going to give us a system of equations, and then they're going to give us an ordered pair. And they want us to determine, is this a solution? Meaning, can I fill this ordered pair into both equations and get a true statement? Remember, every ordered pair is x and y. So when I go to fill this into the top equation, x becomes a 1. I just took the x from the ordered pair. Minus 3 times y. Y is a 3. In order for it to be a true statement, it needs to equal negative 8. Order of operations, we multiply before we subtract. So it's 1 minus 3 times 3 is 9. 1 minus 9 is negative 8. Negative 8 equals negative 8. It checks. Well, we know that it checks the top equation. What they told us is it cannot be a solution unless it works with both. So now let's go ahead and try the second equation. 3 times x. X is really a 1, plus 2 times y, y is really a 3. We have to make sure that that equals 9. This is order of operations. 3 times 1 is 3, 2 times 3 is 6, 3 plus 6 is 9, 9 equals 9, so it checks. So yes, 1, 3, that ordered pair is a solution for this system of equations. Let's do another one just because that was so darn fun, guys. Here's our ordered pair. This is x, this is y. The only way that we can say that it's a solution is if it makes both equations true. 6 times x is 5 minus 7 times y is 3 equals 1. 6 times 5 is 30 minus 7 times 3 is 21. 30 minus 21 is 9. Does 9 equal 1? As soon as you have one that doesn't work, you go ahead and write no. Because the only way that it's going to be yes is if it makes both of them true. Well, I filled it into the top equation and it didn't work, so problem over. That is not a solution. Let's do one more because I really like this. I hope you guys like this too. Here is my ordered pair. This is x, this is y. The only way I can say that this is true is if this ordered pair makes both of those equations true. X is a negative 4 plus 6 equals 4 times y is 1/2. Negative 4 plus 6 is 2. 1/2 of 4 is 2. Yeah, it checks. But I can't say yes yet. You can only say yes if it makes both of them true. So now we need to try the next equation. 2 times x, x is a negative 4, plus 8 times y, y is a 1/2 equals 1. 2 times negative 4 is negative 8, plus 1/2 of 8 is 4. Negative 8 plus 4 is negative, oh, darn it. Negative 4 equals 1, So this is a big no. Even if it makes one equation true, you cannot say that it's a solution unless it makes both equations true. Let's go ahead and start solving by graphing. Use a graph to solve a system of equations. Then we're going to go ahead and check the answer. I always think that it's easier if we can get it into that y equals mx plus b format. So that's where I just kind of put that little hint. If you're like, whoa, where do I start? I really feel like it'll be beneficial because we've graphed y equals mx plus b so much already. If we can get y by itself, we could use that skill to help us. So if I'm looking at the first equation, if I want y by itself, I can take this little chunk, this 2x, and move it to the other side. It's positive here, so to move it, I have to minus. So negative 3y equals negative 2x plus 3. Remember, in y equals mx plus b, the x term comes before the constant. That's why when I move 2x over here, it came before the 3. Now to get y by itself, I need to divide everything by negative 3. Negative cancels a negative, 3 cancels a 3. Y equals negative divided by a negative is a positive. Leave it as a fraction because remember, we are graphing. So this is up 2 to the right 3, up 2 to the right 3. Positive over a negative is negative. 3 divided by 3 is 1. I can graph this. Whatever's after x, that's your starting point. So I start down 1. My slope is 2/3, so up 2 over 1, 2, 3. There are my 2 points. Now what I need to do is graph a line. Alrighty. Perfect. Now I need to go ahead and do the other equation. Again, if we can get y by itself first, that'll help. So I can take this plus 2 and minus it. So y equals x minus 2. Wherever you're starting, okay, so once y is by itself, to see where to start, remember you look after x. So I go down 2. That's your first point. Now in front of x, this is an unwritten 1. That's your slope. 1 is the same thing as 1 over 1, so I go up 1 over 1, up 1 over 1, up 1 over 1. Now I know it only takes 2 points to make a line, but when we're trying to solve by graphing, the more points you have, the more accurate it's going to be. So that's why I went ahead and I did 1, 2, 3, 4 points instead, but now I can really quickly identify the solution. Your solution is the ordered pair where those 2 lines cross. So my solution is 3, 1, because that's where this ordered pair is. Now to make sure that that's really our solution, remember this is the x, this is the y. 2 times x is a 3, minus 3 times y is a 1. We have to make sure that that equals 3. 2 times 3 is 6. Minus 3 times 1 is 3. Well, 6 minus 3 is 3. 3 equals 3. Yep, it checks on the first one. Okay, let's check the second one. Y from the ordered pair is a 1. So 1 plus 2 equals x. X is the first value in my ordered pair, so it's a 3. 1 plus 2 equals 3. 3 equals 3, it checks. So yes, folks, we did it. We found our solution. It checks. The solution for this system of equations is the ordered pair 3, 1. Super fun. Let's keep on going. Okay, if I want y by itself here, I'm going to take this plus 6 and I'm going to move it on over. So I have 2y equals x minus 6. Now to get y by itself, I had to divide everything by 2. So y equals, remember x over 2 is the same thing as 1 over 2 times x. Minus 6 over 2, that's a 3. Here is one equation. Whatever's after x, that's where you start. So I go down 1, 2, 3. Boom. My slope is 1/2, so I go up 1 over 2, up 1 over 2, up 1 over 2. Go ahead and connect it. I hope you guys are having a good time. This is a fun video. Starting a new chapter. All right, let's look at the next one. If I want y by itself, I just got to take this 3 and move it on over. So 4x minus 3 equals y. It's okay that y is on that side. You just need y by itself. Whatever's after x, that's where you're starting. So I'm going down 1, 2, 3. Hey, there's my intersection point. Gotta like that. My slope is 4. That's the same as 4 over 1. So I go up 1, 2, 3, 4. Go to the right 1. Up 1, 2, 3, 4. Go to the right 1. Here is a graph of that system of equations. Now your solution is wherever they intersect. We lucked out big time, you guys. It intersected right where we started. So our intersection point is 0. We did not have to travel to the left or the right. And -3. We just had to go down 3. Now to make sure that that is really a system, this is x, this is y. So I go into, let's start with the top equation. 2 times y is a -3, plus 6 has to equal the x value, which is the first number in my ordered pair. 2 times -3 is -6. -6 plus 6 is 0. Boom, that one checks. Okay, let's check the other one. 4 times x is a 0, equals 3 plus y is a -3. Well, 4 times 0 is 0. +3 plus a -3 is 0. It checks. So yes, folks, that's our answer. The solution to this system of equations is the ordered pair 0, -3. One more time, just to make sure. Okay, if I want y by itself, I can take this -x and add it to the other side. So y would equal +x plus 5. So I stay at 0, go up 1, 2, 3, 4, 5. My slope is an unwritten 1. 1 is the same as 1 over 1. So it's up 1 over 1, up 1 over 1, up 1 over 1. There is my line. Okay, now the next equation. If I want y by itself, I have to take 3x and move it to the other side. So y equals -3x plus 1. After the x is where you start. I'm going to grab a different color here. I'm going to go up 1. Now -3 is the same thing as -3 over 1. So I go down 1, 2, 3, go to the right 1. Down 1, 2, 3, go to the right 1. Let's go ahead and connect the points. When I graph this, I do have an intersection point. Okay, those two lines cross right here. Where do they cross? I go left 1, up 1, 2, 3, 4. So I'm saying that the solution is -1, 4. Now to check it, you go ahead and you fill that in. So y is 4 minus x is -1. It has to equal 5. Well, here I'm minusing a negative. Remember, anytime you minus a negative, you're actually adding. So 4 plus 1 is 5. 5 equals 5. It checks. Now let's see if it fits for the second equation. 3 times -1 plus 4 has to equal 1. Well, 3 times -1 is -3 plus 4. -3 plus 4 is 1. 1 equals 1. It checks. So yes, that is our solution to that system of equations. Our solution is an ordered pair, -1, 4. Now let's see what they want us to do. Whoa, okay. The systems of equations you graphed in the previous examples, they have exactly one solution. What that means is that you do have an intersection point. When you have one solution, your solution is going to be an ordered pair because it is a location on a coordinate plane where the two lines cross. A consistent system is a set of equations or inequalities, which we will shift to later in the chapter, that have one ordered pair or they might have an infinite set of solutions. So here's a really cool thing. Okay, so consistent just means that it has an answer, either one or infinite. Now infinite, what that means is if I go to graph a system, let's say I graph that line, then I go to graph the next one, it ends up being the same line. If you end up with the same line, you have an infinite amount of solutions because lines are infinite. Remember, they continue forever and ever and ever in both directions. So that means that there's an infinite set of ordered pairs that would be on that line. Anything on that line would be a solution. So consistent just means that there is an answer, whether it's one ordered pair like we just saw, or we end up with the same line, meaning that there's an infinite amount of solutions. Inconsistent means that there's no solution. What that means is you have parallel lines. Parallel lines never touch. Your solutions are where your lines intersect. Well, parallel lines never touch, so there's no solution. If you have no solution, it's called an inconsistent system. Okay? You can also classify linear systems by comparing their slopes. If two equations, if they have different slopes, they are called an independent system. Well, if they have different slopes, that means that they're rising and running at different rates, at some point they definitely will cross. So if you have an independent system, you will have a solution. It will be an ordered pair, okay? Dependent system means that they have equal slopes. If they have equal slopes, they're either going to be the same line, meaning you have an infinite amount of solutions, or they're going to be parallel. If they don't start at the same spot and they have the same slope, they're rising and running at the exact same rate. They will never touch. Okay, so independent, different slopes, dependent, equal slopes. So now what they want us to do is classify systems. I know some of you are visual learners like me, so here's just a little graph to kind of show you what's up. This has one solution because those lines cross at one point. They are consistent because they have a solution. They are independent because the only way that two lines intersect like that is if their slopes are different. Okay, this is technically two lines graphed together. They just ended up falling exactly on top of one another. So they are consistent because, hey, there's a solution. Your solution is an infinite amount of solutions. Any ordered pair on that line is a solution. They are dependent because they have the same slope. They have the same slope because they're rising and running and rising or falling and running at the exact same rate, okay? Now here, these are parallel lines, so they're inconsistent because you do not have a solution, but they are dependent. I don't have that there, sorry, my bad. They are dependent because they have the same slope, okay? They're rising and running at the same rate, that's why they never touch. Okay, so what I do when I'm doing this, if they want you to classify a system, I do get y by itself before I start comparing because it's easier to look at the slopes and easier to figure out what the graph would look like. One thing you can do is even sketch the graph to see what happens, okay? Let's go ahead and get y by itself. So on this one, I would minus a 6. So x minus 6 would equal 2y. Divide both sides, or divide everything by 2 on both sides. X over 2 is the same as 1/2 x minus 6 over 2 is 3, so there's the first equation. Now let's do the same thing. I'm just going to grab a different color here. If I want y by itself, I'm going to minus the 3x, so it's negative 3x plus 18. Now to get y by itself, I need to divide everything by negative 6. So y equals negative divided by a negative is a positive. 3 over 6 is 1/2. Positive 18 divided by negative 6 is negative 3. What do you notice about those two equations? I know some of you said they're the same thing. So you guys, what that means is if I went ahead and I graphed them, I'm like, hey, I'm going to go ahead and graph them. Because of the same line, they would end up exactly on top of one another. So that means you have an infinite amount of solutions. Infinite solutions, anything on that line. So if you are classifying, you have to say, is it consistent or inconsistent? If it has a solution, it's consistent. This has an infinite amount. So this is a consistent solution. Then you look at their slopes. If they are the same, they're dependent. If they are different, it's independent. Both of these two equations have slope of 1/2. It's the same, so it's dependent. So this is your solution here. Consistent, dependent. You do have a solution to the system, and the slopes are the same. Let's keep on going. This is kind of the funky part of the day. Okay, if I want to go ahead and get y by itself, let's minus the 4x. So y equals negative 4x plus 1. If I want y by itself, I'm going to go ahead and minus 1. Y equals negative 4x minus 1. Okay, now I like to go ahead and visualize this. Okay, I'm a visual learner. I need to sketch this out. So what I notice is that yes, they do have the same slope. Okay, they have the same slope. So right now I know that they are dependent because dependent means the same slope. So I'm halfway there. But I need to know, are they consistent or inconsistent? Meaning, is there a solution or is there not a solution? So if I graph this one, I go up 1, go down 1, 2, 3, 4, go to the right 1, bam. Okay, they don't have to be perfect. We're just trying to see what we have if we graph this. If I go down 1, there's my starting point. Go down 1, 2, 3, 4, go to the right 1, boom. Okay, so I know it's just a sketch, but if they do not start at the same point and they have the same slope, they are never going to touch. So this is inconsistent. They are parallel lines because they are going to drop 4, run to the right, drop 4, run to the right. So they're going to do the same thing. So this distance that they have apart at the beginning is going to be maintained throughout the graph. So this is dependent, same slope, inconsistent, no solution, they're parallel lines. Okay, let's do another one. If I want y by itself, take this 7x and move it on over. So negative y equals negative 7x minus 11. Divide by negative 1. So y equals negative divided by a negative is a positive 7x. Negative divided by a negative is a positive 11. There's 1. To get y by itself here, divide everything by 3. Y equals 7x plus 33 divided by 3 is 11. Same line. If it's the same line, that means when I go to graph it, wherever it is, it'd be up 11 and it'd be going positive, so it'd be something like this. When I go to graph the next one, it's the same thing. If it's the same thing, you have an infinite amount of solutions, so it's consistent because I have solutions. You look at the slope, the number in front of x. They're the same, so it's dependent. Ta-da! That is 3.1. Oh, let's do one more. Okay, classify. I thought that was the grand finale. Oh no, we got one more. If I want y by itself, hey, y is already by itself. Beautiful. If I want y by itself here, go ahead and divide everything by 5. So y equals 5 divided by 5 is x. 35 divided by 5 is 7. This, if I want to rewrite it so the y is on the left side, you totally can. It's x plus 4. So the first thing I notice here, if I look at the number in front of x, it is an unwritten one for both. If they have the same slope, it's dependent. If they have different slopes, it's independent. Now here, they're starting at different spots. So 1, 2, 3, 4, and it goes up 1 over 1, up 1 over 1. So there's one line. The other one, 4, 5, 6, 7, and it's up 1 over 1, up 1 over 1. So notice again, they would be parallel lines because they're going to continue to go up 1 over 1, up 1 over 1. So whatever the distance they had between the points starting will maintain all the way throughout. So there is no solution. If there's no solution, it's inconsistent. And that is 3.1. So here is your assignment, you guys. I'm thinking it'll probably take maybe about a half hour, so not too bad. You're going to turn to page 186 in your book. Go ahead and do numbers 1 through 13 and 15 to 26. When they ask you to classify, look at the last examples we just did. Classify, you should have 2 words as your answer. Either consistent, if there is a solution, or inconsistent, meaning they're parallel lines. Then your other word, dependent, same slope, or independent, different slopes. Okay, so I'm going to have you go ahead and complete your first book assignment for chapter 3. This is going to be a notebook check, so I just want to make sure that you put in the time to practice and do the best you can to understand the skills that we just covered. Hope you're having a fantastic day, and I'll talk to you soon.